In this last lesson of the Higher Unit 1 Specimen 2 video lesson, we're going to look at question 14 and question 15. So a curve has equation y equals x squared, take away 6x plus 5. We have to find the equation of the tangent to the curve where x is 5. The most common mistake here is just to find the gradient and not go on and use y take b equals mx take a to find the equation. So firstly, to get the gradient at 0.5, you need to differentiate this and then substitute 5 in. So I'm going to do that first. So divide by the x, multiply down by the 2 to get 2x, and this goes to 6, and the constant goes to 0, so take away 6. I then want to sub in 5 here. 2 times 5, take away 6, and x is 5, and this will give me the gradient. So that's going to be 10 take away 6, which is 4. So the gradient at this point is 4. Now, the next thing I need to do is, for my equation of the straight line, for y take b equals mx take a, I not only need a gradient, but I need a point on the line. I want to get an x value, so I need a y value to create a coordinate. So to get the y value, it's dead easy. You just put 5 into this formula here that says y equals. So if I'm putting 5 into that, I'm going to get 5 squared, take away 6 times 5, add 5. Now that's 25, take away 30, add 5. That just goes to 0. So the two things I'm going to use for my y take b equals mx take a, I'm going to use 5, 0. There's my 5 and my 0 for my coordinate, and I'm going to use m equals 4. So y take away 0 equals 4x take away 5. And that just goes to y here, and if I multiply this out, I get 4x take away 20. That's my final answer. Okay, last question. The area of a rectangle can be represented by this formula: a of x equals 24x take away 4x cubed, where x is greater than 0. Find the value of x which maximises the area of the rectangle. So whenever you get a question like this where you've got a formula, you're trying to maximise or minimise, this is an optimisation question. And you don't need to actually prove this formula. All we have to do is differentiate it and prove there's a maximum at a value of x. Okay, so firstly I'm going to write down the formula and then I'm going to differentiate. So a dashed x equals, this will go to 24, multiply down by 3 and reduce it by 1, so minus 12x squared. Now I know the maximum or minimums happen when the a dashed x equals 0, so I'm going to write that down. For max value, let a dashed x equal 0. So that means this bit here is equal to 0, 24 minus 12x squared. I'm then going to use factorising to solve this. So take out a common factor if you can, which is 12 here. So 12 times 2 makes 24, and 12 times x squared gets this. I then know that that must equal 0. Notice there's no x outside the bracket. Some people get mixed up and think x equals 0 just when there's a number here. X can't equal 0 because that wouldn't make this whole thing 0. If you put x as 0 here, you get 12 times 2, and that doesn't make 0. So if there's just a number outside the bracket, you can't make x 0, you just deal with the bracket part. So the bracket part must equal 0, so that means x squared must be 2, because 2 take away 2 makes 0. So to get x, you want to square root this. Notice that's going to give a plus or minus square root 2, but we can discard negative root 2 because we're talking about areas and lengths, and we're not going to use negative values here. So discard that. Okay, so we're going to use root 2, positive root 2, so x, we're going to use root 2. We're going to look at the gradient before and after root 2. So that's what your gradient bit part is, a dashed x, and we're going to look at the slope, and hopefully it comes out as a maximum because that's what we're trying to prove here. So a bit before, now root 2 is about 1.7 something, so I would say before, you can either use 1, or I'm going to use 0 in this case, and then I'm going to use 2 as a bit after, to check what was happening before and after this station point. So if I put 0 into the derivative, 0 here, I'm going to get a positive value, so plus. At the station point we know the gradient's 0, If I put a 2 up in here into the derivative, that's going to generate 4, so that's going to be 48, and if I do 24 take away 48, you're going to get a negative. So positive gradient, 0, negative, which proves a maximum happens at root 2, which is what we're looking for. And to finish it off, the value of x that maximises the area of the rectangle is root 2.